side of the pool that,
Yeah.
you know, is within 12 feet or something. But, you know, I didn't pass the test with a lot. I passed it, or the code, by a lot. I passed it with 74, but I'll take it as a win.
Yeah, right. Yeah.
What was really surprising to me is that electrical wiring methods and electrical materials, I missed two out of two, which was interesting because I'm pretty much up on that. It was like, you know, I kind of felt like in this test, everything that I passed last time, I didn't pass this time.
Okay.
And the things, you know, like I exchanged half for half, and they were just, this one seems substantially more difficult.
Okay.
On the code.
I mean, going over what you did, you know, the example you gave me were the two that you mentioned, you know, the 3,200 square foot home, and they gave the cooking appliance, and you said something else. I didn't catch that second part they gave you.
I think they said, assume, you know, 8,000 watt dryer,
Okay.
and two 3,500 watt cooking appliances, and, you know, like 6,000 watt, you know, wall mounted oven or something to that effect. So it had like a, you know, a few. And then I thought, based off our last time, that I had the cooking appliance calculations down, and evidently I don't.
Well, the service size for an office or a bank, by any chance that, you know, you mentioned 18,000 watts, but then you said 180 VA at 100 receptacles. I mean, that'd be the same number, but did they give you any square footage by any chance on that one? Or do you remember?
No, I don't believe so, because I would have gone to, you know, I could have gone to the table and calculated the VA by square footage.
And then they gave you some other loads. Were they looking for like a total number in amps or VA, or what was the answer looking for?
The answer they were looking for was service disconnect size.
Okay, so like service size.
Yeah.
What were your answers coming up? Were you coming up really close to something, or close to two of them, or not close to any of them? Or?
Not close to either one of them. I was coming up in the middle.
Okay.
And you know, I was searching, and I was kind of running out of, I made sure to take my time all the way across this one. And this was one of the ones that I had flagged. I was like, okay, that one is just, I don't even know. I know it's going to take me a long time. I'll go back to it. I probably flagged 7 of them on this test, where the test previous, I only flagged 3.
Hold on for 1 second. Something just started playing on my side.
Yeah, no big deal.
No idea what that is.
I was actually trying to look through.
Here for drivers to go between South Boston and Hayes County.
A
new toll road now connects the southernmost end of Mopac to.
Somebody, you know, I don't know if I told you that somebody stole my motorcycle out of my garage.
Oh man.
And, you know, so I've been just waiting for my insurance company to finally get around to deciding to pay the claim. But in the meantime, you know, I'd had the police detective call me one night and said that, they'd seen the motorcycle go into an apartment complex because they had a license scanner or something on the gates of that place. But by the time they made it there, it was already gone. But then I got into my toll booth notifications today, and I started opening up those letters, and I found a couple of them that were where somebody, you can see a picture of somebody on the back of it driving to a toll booth with the same. You'd think they would change the license plate out before.
Well, yeah.
Well,
I got a 92 FXR for sale that I just restored.
Yeah, what year?
92.
92 FXR.
Yeah, so it's the Super Glide.
Oh, yeah.
If they don't find it, but anyway, I'm just throwing that out there. You know, I was looking through your the questions, the sheet of questions that people have fed back to you from, and I was trying to find. I did get both motion picture questions, but I think a lot of this was code, right?
Yeah, a lot of it's code.
Yeah. Okay. So
there's a couple of minor calculations in there. You know, there's some disconnects for a motor or whatnot. So I'm interested. Let me see if I can work through these two that you gave me, just out of curiosity, because I'm curious to kind of see what this works out to be. So,
Sure.
if I had a 3,200 square foot dwelling, right? Let me get see if this is going to come back up. Get my pencil just died or something, because it's just not even coming up at all. I must have stepped on it or made it mad or something, but I'll just use a regular one here. So give me just a second. So 3,200 square foot home, that's a real common square footage they've used for a long, long time. And that is, optional method unless they mention otherwise. And since they didn't, we're just going to presume.
You know what? I think I did too on this one. You just spurred something into my head when I was talking with Eric, one of my guys, that's getting going for his master too. I think in my head I used 3,500 instead of the 4,500 on the, just given for small appliances.
Yeah, that might do it. So yeah, it's 1,500 times 3. Yeah, so it'd be 4,500. But 3,200 square foot, and you mentioned that they gave you like the three appliances and the dryer. So just interesting, just so that we can be clear on the appliances, if nothing else. The first thing, of course, is the 3 VA, which is the the lights in the receptacles. So we knocked that out, and that's 9,600 VA. And you're right. Then you add the 1,500 times 3 out of 220.52 A and B, which are the 2 kitchen appliances and the laundry circuit.
Right.
Each one of those at 1,500 VA, so 4,500 VA, and that's definitely something that if you underestimated that would skew your answer a little bit.
Right.
It
might have been within the
yeah
ballpark if I was doing right on the demand factor.
Optional method wise, or standard method wise, then you add these two together, and that would give us 100 11,500. That's what I think that is.
Yep.
11,500. 11,500. Man, I've just totally went too much on that VA. And that's where your first D-rate step would come into play, and you do that prior to doing any of the appliances. So that's the table 220.42. So we take 11,500, and the first 3,500 of that we can't touch.
Yeah.
Is that where you got the 3,500 from? Sure. It's 3,000. No, sorry. It's 3,000 or 3,500. Let me look.
It's 3,000.
It's 3,000. Now you got me doing 3,500. Sorry. 3,000 VA.
So
it's catchy.
You know what? I think I totally blew past 220.42.
Okay.
Didn't even hit the demand factor there.
Yeah. Unless they specifically told you to use the optional method, which they could have, but if they didn't, then you would definitely take this because that's part of the standard method.
Right.
It gives you whatever the difference here would be, 500. Let's see, 11 minus 3 would be 7. 8. Sorry, 8,500.
Yeah.
The calculator here. Let me use it to try and get it in my head.
Yeah, that's exactly what I was having to do just now.
11,500 minus 3,000 is 8,500, right? And that's the balance that we're going to take at the 35%.
Right. So times
29.
5.
So then that, I'm just going to erase this first part here. That brings us to 2975 plus the 3,000 that we took off originally. 5975 seems kind of low, but that should be right. Let me just double check myself. So 3,200 square feet we started with, right?
Yeah.
Times 3 plus the 4,500. Oh, sorry, that's 14,500. What am I doing wrong? So let me. Excuse me.
Oh yeah.
How did I miss that? I'm telling you what. That's.
I don't know. It's been rough on everybody.
3,200 square feet. Let's try this again.
Yeah.
Times 3 VA is going to give us the 9,600, which is what we had before, plus the 4,500 though. I must have forgotten to add those two together, or when I did, no, I added them together. I just goofed and put 11 instead of what this would have been, which would be 14,100 VA.
Yeah, there we go.
There we go.
Okay. So
Then we subtract the 3,000 from that number. That makes more sense.
makes 11,
100, which is what I had up there. That's the balance that ends at times 0.35.
Right.
There we go. And that sounds like I'm closer to where I need to be. 3885 is right.
11,
And then add the 3,000 back to that. 6885 is what I was looking for. And interestingly enough, that same square footage has been, around for a long time. So that 6885 is pretty. I mean, I remember seeing it multiple different ways. So it's you're probably right on the money with that. So, but that's just like the first part of it, because you still have whatever appliances and other items that they gave you.
Right. So, for example, I think it was just one dryer that was 8,000 watts,
Okay.
which just take as that, right, at
Okay.
100%.
8,000 watts.
Yeah.
If it's less than 5, you bump it up to 5. If it's over 5, you take whatever the nameplate is. So whichever is bigger, 5K or the nameplate. So you would add 8,000. So you'd have 6885. You would add straight nameplate then for the dryer if that's what you had. And then you told me you had like a 6,000 watt wall mounted or two 3,500.
It was like, as I recall, it was, I'm trying to jog my memory by looking at 2055. I want to say it was like 3 of them. You could do the 3 combined. And then there was an additional one that you had to use separately. That was like, I want to say it was like 8,000 for one, and then the other 3 were around 3,000 and 3,500, right? So what I did is I combined the other 3, and it was still not over 12 kW, and then I took the 8 kVA.
Well, let me ask you this: when you combine those 3, you were thinking about combining them. Were you trying to combine them into one unit or something like that?
Yeah.
What note tells you to do that?
I was looking at I think it's 3.
Look at note 4. I think note 4 is what you're.
Oh yeah.
For.
Branch circuit load, yeah.
But that right there just tells you.
That's branch circuit.
Yeah, and you're not calculating branch here.
Right.
So each one of these you can't combine these and shift columns. They are what they are. You got to leave them in their columns. You got to process them. Whether they
All the way out.
Now note 3 may come into play because if they're unequal ratings or whatever. But be careful of that cooktop and the wall mount business whenever you're doing service calculation, because it's really completely irrelevant. It would only apply if you're doing a branch. And then there could only be 3, and that's a cooktop and up to 2 wall mounts. And it sounds like you had 4 or maybe some other mix or whatever.
Yeah.
So it didn't really matter what they are. You just got to find out what column they
take them
fit
at
in.
face value and run them through their respective columns.
That's right. So you told me originally 2 of them that were 3,200 and one of them was like 6,000. Let's just say that's what they were. I mean, if there was a fourth one, you would just add that to whatever column they are. Now, if I had 3 of them that were a 6 and 2 35s, all the 3 of those would be column B, because they're all 3,500 or larger up to 8.875. So I'm looking at row 3 then in the column B, which is going to be a 55%, is it?
Yeah, 55.
So you add them up, but only to just make the math easy. So it's 7 and 6, 13, 13.5, is it? Let's see. Here I go again trying to do my math without a calculator.
I got 13, right?
times 2 plus the 6,000. Yeah, 13 even, 13,000 VA or watts. VA really, I guess, or watts really, actually. And then we're going to multiply that times the 55.55 in row 3. So you have to be on the row depending on the number that you have and do your own derating math. So times 0.55 is 7150. And that 7150, of course, would be your demand factor that goes in up with the rest of the stuff that you've got, running up there.
Mm-hmm.
So you've got 6885 for the lights and plugs, and then you've got the dryer that was plus 8,000, and then you got the 7150 VA for the ranges. Presuming those numbers were what you had, or some.
It's pretty similar.
Yeah. So just remember, you will have to take the derating step for the lights and plugs. After you had the 4,500. Now you do include the 4,500 in that first step, so they do get derated. That's sometimes easy to forget and try to not derate it, but that gets derated, and then Note 4 is only for branch, not for services. So no adding anything.
I actually had I'm trying to remember on the electric control devices and disconnecting means. The one that I missed may have been the one with we already talked about with the receptacles that we hadn't reviewed yet since we started with this one. And I'm glad we went through this because it reminded me of the minor but majorly affecting steps that I missed.
Right.
The branch circuits calculations and conductors, that one was, I even though I only got half of those right, I felt pretty good about them.
Okay.
Feeders, I felt good. Service equipment, and separately derived systems, I got 8 out of 4. There was some, I think what I'm doing in my head is there was very similar questions in the code sections of this test that was almost parallel to what was in the calculations.
Oh, you mean like in the annex?
No, like in the calculations portion of the test, I saw questions later on in the code portion of the test that were very, very similarly worded or phrased. It was like, I don't know if they do this, but it was almost like that test was a pair, like a match set. For whatever.
I haven't ever heard that before, but I think I like the idea behind it, because if you're trying to remember questions later, it'll kind of confuse you.
Yeah.
Which part went with which part.
Yeah, that's kind of where I'm at now, because I'm looking at my calculations result page, and it's funny. I actually.
Well, then in that second line item where you got 4 out of 8, right? Did you have a lot of supply side bonding jumpers or bonding jumper calculations or parallel sets of feeders?
I did. A lot of the 250, 122.
Yeah.
Back and forth with multiple feeder types and sizes, a lot of them.
You feel like you got those nailed down pretty well, or was that part of your confusion? Or
no, I felt really pretty good about them. Once you figure it out, you get the circular mills, and then you reference back to that table for your parallel sets for the comprehensive size of the wire, right?
Well, that second row is where that stuff would fall primarily. So you're looking at either you did real well on those and bombed the other half that were not that type of calculation, which could be really a number of things. But if you felt pretty comfortable with that, I don't want to redo that. But
the way I will say, the way that they worded some of them was much more confusing and hard to comprehend on this test than previously, and there was a bunch of parallel service bonding questions
Yeah.
and calculations. Like not only that, but let's see what else. Not only the equipment grounding conductor, but main bonding jumper size.
Yeah.
Right. And it took a minute to just dig through it. You know what I mean?
Yeah.
But I didn't feel
Equipment grounding conductor and main bonding jumper are two different tables.
right.
Okay.
Right. And then on, I think the one that I missed on the motors and generators was what was it? Something, trying to remember. But I think maybe we should probably go ahead and think about service equipment and maybe practice one of those. The separately derived system, that's transformers. So I'm not really seeing.
Could be transformers or generators, anything
Yeah.
that produces, electricity that doesn't have, doesn't have a tie to it, to the physical tie to the normal service.
Right.
But usually those are grounding questions or something related to
Yeah.
like the XO or the SBJ. The other question that you remembered, which was the service size based on the the receptacles in office building.
Yeah.
The derating for receptacles in any case in commercial would only be done if it was a service calculation. So do you remember if you took any derating of any of your math on that one?
I don't think I did. I think that's where I was at, was just.
Was it a single phase or three phase service? Was it like 120, 208 or single phase or three phase, or do you remember?
No, I don't think it said. I think it was just like, because it was for the disconnect size in amperage.
We don't rate disconnects usually in VA, which is why I'd kind of need to know what the service is to be able to get the ampacity for, to relate to the disconnect size. But I mean, the one thing about that would be, the 40 kVA, let's presume it was a single phase or we could do it both ways, single phase or three phase really for that matter.
Yeah. I did have a bunch of three-phase questions, so we can assume that.
There was three. Okay. All right. It makes sense in a commercial building. I mean, usually those are those not usually. Sometimes they're three-phase, sometimes they're not. But so you gave me that they gave you 40 kVA of additional loads. They didn't really tell you what they were. They just said they were. Did they say anything about continuous duty anywhere about any of those loads or no?
No, they didn't say anything about motors or anything. That's what it was, kind of very simply worded, but that's kind of what made it so confusing.
Right. Yeah. So let's just say that we had, let's say we had 100 outlets for receptacles, which jives with 18,000. So it could have been one or the other, but
right.
And we're talking about a service size, right? So
yeah.
And you did mention that they said after all derates or all discounts or something have been applied.
Yeah.
The only thing is missing the square footage bothers me a little bit, because without that square footage, it's really hard to take a derate when you would normally. I mean, but if you don't know what the square footage is, it's really hard to do that.
Yeah, and that's where I was looking is, I was looking at 220, what is it?
44?
Huh?
220.44?
Well, it's
220.14.
in office buildings, where blah, blah, blah. Where am I at here? And no, receptacle outlets, and receptacle outlets, except covered 22014. Receptacle outlets shall not be calculated less than 180 volt amperes for each single yoke. Right.
Mm-hmm. And as a branch, that's absolutely true. That would be the minimum calculation, and there wouldn't be any derating in the branch. You'd have to provide 180 VA for every receptacle on every branch circuit. So all your branch circuits effectively would be 100% of whatever your total number of receptacles per circuit, right? At 180
right.
VA. But we're talking about a service calculation, so we're looking for, you know, some sort of allowance to use 220.44, which is on the next page over. That one though, so all of this, if it's an office or a bank, that's where it gets tricky.
Oh,
If you look at 220.14K though, 220.14K is the controlling article in this question though,
Right.
because this office or bank would be treated a little bit differently than if it was a restaurant or some other commercial building.
right.
So K1 says, look, do it just like you would under I. And I would allow you to take the derating if you were allowed to. So you would derate section I. So you would take the 100 outlets, you'd multiply that times the 180 VA, which would give you, I think 180,000 VA, or is it 18,000? Just add 1 0, right?
Yeah, that actually sounds, I think that's, no, would it be? I don't know. Let me get my-
18,000, no, you're right, 18,000 VA. Just add 1 0. So, or 18K VA, that puts you over that 10K minimum threshold, which is where that table 220.44 starts at. So we would take basically the first 10K at 100%, but that 8 that's left over, we're going to take half of that and throw it away, keep the other half. So we're at a net of the 10 plus the 4,000, so 14,000 VA when that derating step is taken.
So we're going to take the 10K out of it
At 100%.
at 100%. So that leaves us with 8,000
Times 0.5.
times point. Oh yeah, 5 gives us 4.
Yep.
So now we're sitting at the
4 plus the 10,000. Don't forget to add it back.
right. Oh, okay, yeah.
Yep.
Right.
And that's what gives you the 14,000, VA total. And then, the second note in case says, look, but you can't be less than whatever the square footage of the place is times 1 VA per square foot. That's the problem in the case if I don't know what the square footage is. I mean, what if it's 16,000 square foot office building, right?
Right. Okay.
So-
Yeah, I'm probably just misremembering the
Yeah.
entirety of the question.
Without that square footage, it makes it real hard to really apply K correctly because I mean, if I don't know what the square footage is, which I almost always would in reality, but on a test, if I don't, I'm almost hesitant to even take the derating. I may just leave it at 18,000 and call it a day and not take it because then I don't really know where it's safe to stop my my deratable number. So I mean, presuming they gave you the square footage and you just didn't notice it, then that would be the right way, plus whatever the other 40,000 that you have, and then divide it out by whatever the voltage that they give you. If they didn't give you the square footage, maybe try it at 8,000 and add the 40K to that, so you'd have 58,000, divided by whatever the system voltage
Yeah, and
is.
I'm certain that I didn't look to apply 220/44. I was looking all on, I through K and trying to think it through,
Yeah.
but and probably I just don't remember the square footage,
Yeah.
being given.
It almost makes me feel like they're trying to bait you though with that whole after all applicable D rates have been applied. Anytime they say that, I almost want to do the opposite. Because it's
Right.
so. I mean, obviously they you should know to take the D rates or not. And so if they tell you to do that, then that's kind of a warning sign that they're probably leading you down the path. But I mean, 18,000 plus the 40. Let's just assume it was a 3-phase 208 volt, right? So a 3-phase. 208 volt. The way to make that math work would be to take the square root of 3. So I'd take the voltage of 208 times 1.73 before I do my. So
Right,
it comes out to be
which gives us the
359.84.
Yeah,
Right.
359.
So if we took 58,000, let's just assume that our D rating was the right or not allowable. So if we took 18,000 plus the 40,000.
Right.
58,000 and divided that by 359.84. Help if I typed it in there, right? I'm looking at 161, miscellaneous amps. that would round up to a 175 amp, which is the next standard size. And you'd go to page 100 in your code book for standard service sizes is the same thing as a standard breaker size. If that wasn't close, then the next route would be to try it with the derating, presuming that the square footage was less than your calculated value. Say it was 11,000 square feet or 12,000 square feet. I would still.
I need to write that down because I spent so much. Let me grab a red pen real quick.
Okay.
I spent so much time looking for that because it's just not one of those pages that I've turned to a lot.
Yeah.
And I was like,
page 100, they put it on an easy page to remember too, because it's just, it's a century mark. Now, here's an interesting thing that I just figured out. So if you do it at the 14,000 mark, right? In other words, if you take the derating and just assume your square footage was less than your calculated value, you take 14,000 plus the 40K, divide that out by 359.84, it comes out to be 150.066. So what I'm saying is that again, just to kind of explore this possibility. So if I do the same calculation, but instead of taking the 18,000 at full value, and presuming they allowed me to take the derate, then that gives me, the 14,000 that we calculated, right? That's the derated receptacle load, plus the 40K of other loads they gave you, that's 54,000. And if I were to divide that number out by that same 359.84, what I get is 150.06. That's still going to be a 175 because if I go over, I go over. I don't care how minor it is, it's over.
right.
Yeah, be careful of that because I could see them expecting you to round back down to 150, and that would not be the right direction to go. I mean, in the field, yeah, I'd probably stay with the 150, because that's probably the chances. But again, strictly by code, you're looking at rounding that up because you have to provide for at least 150 and 0.06 of an amp. That, 0.5 stuff doesn't have any play here. It's just, this is a minimum calculation. So minimums always round up no matter what you're really looking at. So that would still round up to 175.
Right.
So either one of those two examples, we got the same breaker size. If they used a single phase, 240, 208 volt, I mean, it's still the same. I mean, you have two choices. It's either 58,000 or 54,000. That's really all there is to it. And unless the square footage is in there, the square footage is the one wrinkle, right? Remember, when I'm doing that section for the receptacles, you always got to remember section K is a two different calculation, and you pick the larger of whichever two calculations you end up with. So if your square footage would have been 16,000, let's say, square feet, I would have taken the 18,000 VA that I got from the calculation under I, done the minus 10K, 50% of the rest, and I would end up with 14,000 left over, right?
Right.
That number, if the square footage is 16,000, well, then the 16,000 at 1 VA would be the minimum amount, and it would trump the calculated value, and I'd end up with 16,000 VA as a minimum number, and I would not be allowed to derate that number at all.
Okay.
So you just remember square footage, it's either the square footage at full face value times 1 VA or your calculated value, whichever is the larger of the two calculated methods. For banks or office buildings, either one when it comes to receptacle loads. I wish there was a little bit more detail on that, because I feel like we're kind of stepping all over what it could be, but that at least kind of gives you a little bit more ammunition. If they didn't give you the voltage, then I don't know how you can move forward with a question like that.
They must have, and I'm just, misremembering.
Yeah. Or they could ask you for the service size in VA, which means you don't really have to do anything other than calculate it there. I mean, Because I mean, I've seen them ask for that. I mean, typically we convert it to amps before we do anything with it, but that doesn't necessarily mean they have to ask you that way.
Right.
Did you have any? I mean, did you have any multi-outlet assembly questions that gave you a hard time, or were there any?
No, they were actually, because we deal with those, you know, at work all the time. So they're always in my head. It's all basically that we put in certain broadcast racks or, you know, consoles or whatever.
Okay.
So it just really makes kind of sense to me.
Okay.
The way that, you know, the multi-outlet assemblies work. I did have one control device question that I was trying to remember that was like an intrinsically safe circuit controlling motors or motor control.
Okay.
Trying to remember.
So intrinsically safe is a hazardous location qualification. So that's typically where you'd run across questions like that. But
Yeah, it might have been, and that one might have been in the special occupancies, equipment, and conditions.
trying to remember exactly which. Yeah, it's 504 is the article number.
Yeah.
Were they asking you for a calculation though of it?
Yeah. Maybe not. Maybe I'm thinking of the code. In the code, there was something about. I want to say it was like in a given motor control circuit in this condition, and had to be like, you were calculating the wire size, you know, it gives you, you end up with like 15 amps for number 14.
Was it for so it was a motor control kind of question?
I kind of recall, but again, I may be
16 gauge or 18 gauge by any chance, or?
Yeah, it might have been.
Look at 430.72. There, you know, you're not the only one that's had some kind of control questions about whether or not it, what amperage you'd have given certain conditions. And those are, you know, building wire, 14 gauge is the smallest we're allowed to use per code, except certain provisions allow for 16 or 18 gauge under certain circumstances. And motor control wiring is one of those. Allowable uses, and it's on page. Well, I'm using my 2017 book, so I better not give you.
Yeah, it's 322, table 430.72B.
Yeah.
Yeah.
So you'll notice the first top two rows are 18 and 16 gauge respectively, and depending on whether or not they leave the enclosure, or stay in the enclosure, or whether or not they've got separate fusing or not, there's different values, but typically it's either 7 or 10 or 25 or 40 as a calculation for, it's a maximum value really is what you're allowed to presume those to have as far as the capacity. And that matches if you go to 240.4D. 240.4D also has those two conductor sizes listed, and you have the same fuse allowances with a 7 and 10 amp fuse respectively, given, you know, certain circumstances there as well.
Yeah.
It's not really a calculation though. I mean, it's more of a, I guess, a table reference. I mean, so
Yeah.
I don't want to presume that that's what you had, but that's a question that's come up recently as far as like the ampacity of a 16.
And you know, I may be, like I said, confusing with the code section. It's
now there are some power limited you know, ampacities and stuff in chapter 7, because you have fire alarm, which is either power or limited. What is it? Limited power. What is the? I'm trying to remember exactly the way it's worded. Non-power limited or power limited. And I've seen, you know, ampacity minimum and maximums in that section, but not really any calculations per se that I'm aware of. But if you look at 760, which is fire alarm systems, there's power limited and non-power limited fire alarm circuits. And there are some weird numbers back there that you know, I've had to use calculations before in the field, but not necessarily on a test. But and I know there are some sections that are out of this article that have been known to be on the test before as well. So who knows if that helps. But there is circuit conductors under 760.49, like the 16 gauge and 18 gauge allowance is there. Installation type requirements. What was that number that I heard on somebody else's test that was weird? There's a D rating under .51B, but I don't know if that's really what we're talking about. But that's power limited. It's not intrinsically safe circuits, which is what you were mentioning. So,
Yeah, well, it's I guess it's so far gone, and they were such unusual. A lot of them were so unusual. You know, these onesie twosie questions.
Yeah.
You know, like renewable energy technologies. I had that one, and I got that one right. You know, and that one was like, oh, you know what I did get, and I don't know if I got them right, is the ventilation space about electric vehicle chargers.
Okay.
I got 2 of those questions.
Really?
Yeah, which one of them had to have been probably the special occupancies, equipment, and conditions, maybe.
That would have been where those would have fit. Absolutely.
So there was, and we never talked about that, but that was in the, hold on, let me go in my,
Well, let me ask you a couple of things. Were they single phase or 3-phase questions, or were there one of each?
I think it was 3-phase, and it was like, it gave you 2 different loads, like
30
one
amp
of
or
them.
40 amp or something?
Yeah, and so hold on, it's going to come back to me real quick. Let me get back to that. That is in
525.52 or 552. Never mind.
No, that's park trailers. No, it's in
525.52 is what I was thinking, but
chapter 6, I think.
it's not 525.
Yeah, it's like
Come on.
and electric welders, electrified vehicle power transfer, 625, page 531.
That's what it is.
Yeah.
620. What did you say?
Well,
25.52.
625, page 531. I haven't got there yet. But there's a table. Yeah, here it is. And so they give you, in the 2020, it's on page 534. And so it was like, they gave me 15 and I want to say like a 20 and a 30 amp, right?
Are you on the B table or the A table?
Why am I on the B? I was on the B table for
Okay,
a reason.
that's good, because that should be cubic feet instead of metric meters or whatever.
Right.
Cubic meters.
And so then I looked, at, it was single phase though,
Okay.
because I remember doing, volts, amps divided by 718, or
You don't have to do any of that jazz down there at the bottom. Just use,
oh, okay.
because so the table values, if you were to try, so like if you had a 15 amp that was like a 120 volt, right?
Uh-huh.
That means that I'd be with a 20 like single phase 240 volt or 120/240 volt system.
Right.
That's 74 cubic feet that I'd have to have for that 15 amp charger.
Right.
Be careful, because if they gave you only 120 or if they gave you 120/240, I've heard them, people say that they kind of gave them specifically one or the other, but if it was 120/240 volt, then it'd be 74, cubic feet per minute of for that one charger, and then you would just simply add it to whatever the other charger value
So
is.
let's say it was the 15 and the 30, I would add the 74 and the 148, and that's my
You're
answer.
done. Yeah. You're done.
But see, and I ended up drilling down and working it back and forth a whole bunch, but I could never get my answer to correlate with any of the answers that they had.
Oh, I can tell you that if you were to use the formulas instead of the table, you'd get the same exact answer because the formulas are used to populate the table. So if you have a 15 amp and a 30 amp, I mean, it's only going to be 74 and 148. The only difference would be if you're in the wrong column, if they're giving you 120 and you're using 120/240 volt column or vice versa, that could confuse you. Or if they're asking you for meters per, or it'd be cubic meters instead of cubic feet, which is the other table A. But that's unlikely that they do that. But
No, it was cubic feet per minute, because I remember very specifically looking at this table, and I remember I'm remembering 74 and 148, but it was just like, and you know what it may have been is I kind of wonder if they gave me one that was 120 and then one was 3-phase 240 or something.
Yeah, very well could have been.
Or 208Y, and I was thinking, oh, it's 208 single phase, because you know what I mean?
Yep. No, totally do it. Don't worry about those formulas. That's all I can tell you. Those formulas are just there to bait you, but they don't do you any good.
Okay.
Unless they gave you like a 25 amp charger, and then you're faced with either do you extrapolate the values there, or then do you go to the formulas? And I would go to the formulas in that case just to be on the safe side.
Right.
But, I mean, if it's flat out what one of those rows, there's no point in it. You get the same number, just take a lot more time to get there.
Yeah. Well, hey, I'm glad we're not getting cut off with ERCOT.
Oh man, well, I just got an email at the city about that too. I didn't pay much attention to it, but
They had a press conference when I was about 3 o'clock, and they were like, well, we're almost at the emergency threshold. There's more providers that are, down for maintenance right now. And, something about West Texas, due to the high pressure, there's not a lot of wind moving. So, we may have rolling blackouts. We're 11,000 megawatts short again.
11,000 megawatts. 11,000 megawatts. Wow, that's a big number.
I know, they're like, yeah, it's probably power 2.5 million homes, blah, 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 blah. And I'm like, you have one job.
I'm trying to remember, I just saw something real fleeting in the inside of my eye earlier today. There's something about ERCOT that they'd sent some request to, here it is, request for ERCOT. So, that they're saying that reduce electrical use as much as possible through Friday. There you go.
Well, I mean, it's like, it's like I said to my project manager this afternoon on the way home. I'm like, it's June in Texas.
Yeah.
It's going to be hot.
And July and August it'll be even worse. So if they're at this point in June, what in the heck do we have in store for us in August?
I know. I might as well break the generator out and get a fuel trailer.
I'm telling you, if they keep messing around like this, they're gonna make enough people mad that eventually, I mean, the state was almost in the middle of their business already in this legislation session. You have rolling blackouts and see what happens in 2 years when the state meets again. I guarantee you it's going to not be pretty.
Yeah. Well, I guess they're probably shielded from the special sessions because it's not already on the agenda. Is that how that works?
Yeah. I think the special sessions are already called for whatever they, got working on, but still, I mean, I think they had there was one bill they passed. I don't remember what it had to do with it, but I mean, the city of Austin has its own utility, and so they interface with ERCOT, but I don't think they're necessarily, I think they buy or sell or something according to whatever those rates are. But solar is really a big thing right now in Austin. It has been for a while, and Austin Energy even has a couple of farms that they operate that are solar driven. some several megawatt size. So it's definitely
Mhm.
helpful. But at least those are working now, like they weren't working when it was snowing.
Well, see, I talked to my guys up in at the Bristol ESPN campus, and I'm like, my counterpart, facilities director out there, I'm like, Rich, what do you guys do with the panels? When it snows? And he goes, nothing. I'm like,
Yeah.
what do you mean nothing? He goes, yeah, we don't. I'm like, you don't go out with a squeegee and like clean them off?
Yeah,
and
right.
everything?" And he's like, no, I don't have the manpower for that.
Yeah. Yeah. It would take you days to do that though, because these are thousands of panels. So, you'd be out there with a squeegee for a couple of
Then it'd
watts.
be all frozen, and you wouldn't probably be able
Yeah.
to do anything with it anyway.
Yeah. Maybe you hit it with a flyover and some de-icer or something. Be about all you'd want to try to do. But
Right.
yeah, I don't know. That's I didn't hear that. That's it's interesting.
Yeah, for the rest of the week probably. So I did miss 2 on calculations and theory.
Okay, that's Ohm's law.
Yeah, which is, I didn't have any resistors.
Did you have any solar panels? Come to think of it, did you have any solar panels that were in series or parallel, or any sort of arrays, or 10 of them linked together, or 20 of
No,
them?
I don't think so.
Batteries?
Mm-mm.
Okay.
No, and it wasn't like I want to say it might have been series parallel resistance, like a combination circuit.
Really?
But that's just kind of what's sticking in my head at the moment. That might have been from our practice.
Yeah, combo circuits have not been anything I've seen in, I don't think ever, really, because series combination are a little bit more complicated. But I wouldn't put past them. You very well could be the first one of the many that may have them. You collapse them is what I can tell you.
Yeah. Well, I was just thinking about something to practice, because I feel like, I felt really confident in this second testing, and I did better than when I passed the code. But the math portion of it, it's like I'm going into it, and even now, I'm kind of at a loss for what to practice, because I've been studying so much and, have the frame of reference.
What did you make on it?
46, which is what I'm saying is it was actually worse than last time.
Yeah.
The last test, so I got 14 correct out of 30. And the last test, let's see. Hold on. Gotta find where I have 2 sets of test results, and I got one from one and not the other
14
one.
out of 30.
So, yeah, this time I got 14 out of 30, and last time I got 15 out of 30.
Great. So I managed to make you lose a point. That's. I feel like I've cheated something there.
But what's so funny about it is, like, calculations and theory, I got 2 out of 2. Electrical services and that I got 5 out of 8, which I got 4 out of 8 this most recent time. Feeders, I got 0 out of 3 last time, but this time I got 2 out of 3.
Okay.
You're
all over the
and
map.
then, like, motors and generators, in the first test I took, I got 2 out of 6, but this time I got 5 out of 6.
Yeah.
You
did better with some core things that we covered, but overall you lost a little bit of ground.
Yeah, which that's what I meant about it. It was really a substantially different test that I took the second time than I did the first time, because it just by looking at the correlation of what I missed and what I didn't, had I had the test that I took the first time, I feel very confident I would have passed.
Yeah. So it's the onesies, it's the small ones and twosies that are really tripping you up, and it's probably just the wording of it, because just a couple of them that you've mentioned to me, they've been probably very specifically down to exactly the way it's worded and whether or not you're either falling for it or including it, or whichever's
Right.
relevant. And those are the toughest ones because I mean, without some groundwork or better understanding where to direct you, it's hard to know. I mean
Yeah, for sure. So I mean, I feel good about where we're at right now.
Okay.
For my test on Thursday because of reviewing the service calculation questions. I know I probably had. Well, I mean, let's see. Let me look at the correct one.
Did you have any optional method stuff at all?
No, I didn't.
Okay.
And I had questions specifically say using the standard method, because I wanted to delve right into optional method.
Yeah.
Because it seemed easier thing to do with the way they answered their question.
Did you have any conduit fill or raceway sectional sizing or?
I did. I had a lot of the, and this may be code again, but I had a bunch of steel metal raceway or
Yeah. Okay.
flooring raceway. And I had a gutter box, box fill calculation, but I felt good about that. I felt good about my, and I think that was probably,
That was in your chapter 3 stuff, which had been row 5, I think.
yeah, the branch circuit and calculations.
So I mean, if you did okay on those, I mean, typically if you have conduit fill, they're trick questions or they're ones that are marginally more complex because than just a regular.
Yeah, I do recall the couple of them had it was like 5 3/0 and a few number 10s, a few number 8s, and then we had to do ultimately it was like with all of these and the D ratings, what size pipe do you need to use? You know what I'm saying?
Yeah. You feel pretty good about that?
Yeah, I did. I really did.
Okay.
Because you just go through and get the circular mills, and then you're over 3 current carrying conductors in the pipe, and so you go to your standard.
You're mixing a couple of things together. So was it a wire capacity calculation or was it a conduit fill?
Oh, it's conduit fill.
So the number of current carrying conductors wouldn't really, I mean, in the field they do tie together, don't get me wrong. But strictly as a conduit fill, it's just a physical property. Mm-hmm. So the number of them being current carrying, you don't want to know what they are really, to be honest, because that'll just trip you up. But
right.
You got 5.
I think I'm combining two questions.
Could be. Nipple fills are 24 inches or less, mm-hmm. And the wire ampacity D rating for the number of current carrying conductors doesn't start until after 24 inches. So I mean, there's some tie-ins there, but if you just have a bunch of them, but it's not the circular mills that you use; it's the area in inches square of the conductor, right? So
right, with the insulation.
Yeah.
Right.
And be careful if you're trying to figure one out and your answer comes to be, very, very close to one row or the other. For example, if let's just say that you were trying to calculate like how many 750 kc mills you can fit in a EMT or something. If you look at the EMT table, for example, 750 kc mill is pretty good size. If you were to calculate that out, let me see here. I'm trying to go to chapter 9, table 4, EMT. There was this question that had, and the way they set it up was kind of impressive, if you ask me. But it was basically, it was a rigid conduit, is what it was, if I'm not mistaken. But either way, EMT, for example, if you look at 3.5 inch under the 40% fill, you have a value of 4.618, right?
Mm-hmm.
So they gave these 4 750 kc mills some kind of insulation, and when you did the math, it came out to be 4 0.678 or something like that, which is just so, I mean, it's in the tens of thousands of inches of area that you miss. And so it's such a small amount. So you round up to a 4-inch is what they were trying to get you to do, because you went over the 4.618. But remember, if you have all same size conductors, note 7 on the preceding page gives you an allowance or a cushion of an additional 20%.
That's in what page is that on?
It'd be chapter 9, note 7. So it would be the note right in front of the table 4. If you were at the table 4 in chapter 9, I've got my 2017 in front of me, so I'd give you the wrong page number if I gave it to you. But
Yeah. So note
7.
Note 7. Oh yeah, that's the round up at 0.8, not 0.5.
Yeah. So I mean, if I'm that close to a row, and like literally in the tens of thousands, and then I round up, really, then I have to go back and recalculate it as if I was trying to use the 3.5-inch number, the 4.618, and to divide those numbers into that to see if I could get away with the 0.8 rule. In other words, is my calculated value with the smaller conduit size going to give me some value that gives me 0.8, as a final answer?
Mhm.
Now, in the case you gave me, those are all different wire sizes, so that wouldn't apply. But just those are things to just watch out for. And then there was also, I think one of the masters had one of the LFMCs that were either A, B, or C type or something like that.
Oh yeah, I did get that one.
Okay. Was that easy enough for you to navigate? Did you pick the right one? Okay.
Yeah, I just had to make sure I was paying attention to which one it was.
All right.
And
that's really, I mean, other than like, multi-wire conductors would be considered a single wire. So if they give you, like a 16-3 or something, that's just a single wire. And if you've got a ground wire in there too, then that's just 2 wires, which is a different column, for fill value, because there's just 2 wires at that point. So.
Right. Why, I guess is a better idea. Why did National Electric Code decide that it was fine to run Romex and Conduit?
Well, I mean, it's not really fine to run it in Conduit. I mean, it's okay to do it in certain cases, but you wouldn't want to do it, for all intents and purposes for the entire raceway length, and
Right.
you wouldn't want to try to pull it through like it was just standard building wire.
Right. So is it basically just for like
Protection.
a nipple from coming down from the garage or something?
Yeah.
Is that the intent of it?
Yeah. The only time you'd want to bundle it inside a conduit is if you're just trying to keep it from getting nails or nicked or run over, damaged or whatever. But I think there's even a rule somewhere that you can't put it for more than 20% of its length, 20 feet or something. And in like an industrial building,
okay.
Same thing with SO cords. I'm getting confused here. SO cords have the same thing, because you're not supposed to use those for permanent wiring methods, but yet, you can put them in conduit if you're in certain cases, you try to keep them protected. But why did you ask that?
It's just I'd seen somebody go. Where was I? I was doing a job walk, and I saw, I don't know, from to, like they had taken a rigid coupling and an EMT connector and a 2-screw Romex connector.
Okay.
To transition into a panel or something, or a box.
Probably illegal. It doesn't sound.
Oh yeah, that's what it was. It was actually outdoor. I was fishing a bass tournament last month. Actually, the day of my test last month.
Yeah.
When I left, I went straight up to the lake to go fish. And when we were doing the weigh-in on Sunday, it was like a big pavilion up at the lake, and they had done that.
Well, yeah, there's a lot of things that happen way out there that.
Yeah, exactly. I was like, what's speaking? And then it's something that sparked me is what I was thinking. Well, so I think I'm going to be in pretty good shape. I got tomorrow and Wednesday night that I'm going to hit all the practice exams that you're giving me again.
Okay.
And just get myself, going through. I think it's a lot less stressful, probably, only having to worry about, the first portion of the test.
Oh yeah, yeah. I'm sure. Because really now, I mean, you can take all the time you need and not feel like you're, just getting ready for the next phase. So, I mean, it is definitely going to put you in a different position. And you might get lucky and get some of the first questions you have in the first test this next third time. I mean, it's always going to be a little bit different exams.
So are there do they have 5 versions of the test, or is it just random selection?
Zillion versions. It's always going to be different.
Okay.
Yeah. Yeah. They have
they just have a pool of questions.
Yep. And they've got every question identified as to how hard it is or how many people get it right or wrong. And so they give you some percentage of a mix of each one of those out of each category, and they just dump it in a test every time. So in fact, your test version doesn't even exist until the night before your test, and they load it onto the server wherever you're going.
Okay.
Yeah.
Okay.
I mean, there's some 6,000, 7,000 questions. So I mean, they just randomly populate them, but there are some core ones that they seem to ask all the time, and I don't know if those are just the questions they use to kind of verify that you're alive and that you're not cheating or something. I'm not sure why, but you'll get some percentage that'll be either the same or pretty close, and then you'll get some percentage that'll be different every time. But
yep.
I
Mitchell, I appreciate it a whole bunch.
Yeah.
I know you're a busy man like I am, and
well, yeah, like I said, I got sick last week from that COVID. I got a second COVID shot. Man, it laid me out for 2 days.
Huh?
I don't even remember what happened Thursday, much less the Friday, but feel better now 4 days later.
It's all good, man. It's all good.
If you think of another question though that you got stuck on, or if it comes to mind, don't hesitate to text me.
Yeah.
And what I can do is try to work it out or ask you whatever other questions I need to know to work it out, and I'd be happy to do that. Just you never know. 3:00 in the morning, it might come to you.
Yep. Sounds good. Well, I really appreciate it, my friend, and I think I'm gonna do it this time.
Okay, I do too. I think you're gonna be fine. You're in the right spots in code book, so just take your time, breathe deep, and over through it.
Perfect. Well, thank you very much, Mitchell.
Yep.
Have a great evening.
Let me know.
I will for sure. All right.
Bye. Hey, but how did you do in the fishing contest? I left already. All right.